Okay. Share the screen. All right, so up until now, we'd actually just been doing simple things with an interactive. So what we're going to do is we're actually going to go through and just show you how do you actually make this into a file that you can run. So just to provide a quick example, we said print hello world, print 2 + 2. So we have to type that in. What if we want to actually save this information so that we can actually run it? Well, the thing that you can do, at least from the command line perspective, is to go into an editor and actually type these commands in. So let's actually exit out of Python, which is you can do by that command. And we'll use one of the editors that we have on a Mac. It's called Pico, or there's a text edit. So any of the files that any of the editors that you can use that doesn't put around all those fonts and size information, you can use that. So let's call this So I just call it, you can call it whatever you want, .pi. I called it my first program .py. And now I will just say print hello world, then print 2 + 2. Okay. That's it. Give it out. So in this case, you can do a Control X to get exit. Say yes. At the command line, we want to know where we are. So this is a Unix command called print working directory, pwd. You just need to know that where that program got stored. And this is typically what will happen with a lot of people who try to, maybe on a Windows machine, is that sometimes Windows isn't very explicit about where it stores things. So you have to sort of be careful where that's located. So to run the program, you just say Python my first program.py. Just program. Right. Nothing very elaborate, but the fact that you can do this gives you hope to write a program that is 1,000, 100,000, million lines of code. This is where you start, and it's fairly straightforward. In fact, when I ever have a problem with any large programs, I always go back to this. I always go back to something that's a few lines of code and see if it's working. Particularly if I'm trying to understand a certain concept, I always go back to hello world. I still put print hello world and 2 + 2 just out of habit. Maybe it's superstition, because I know it works. Then I'll add more complicated things to it. All right, so this is through a command line. For those of you who are on a PC, what you will probably likely use is the idle interface, which on a Mac you can actually run idle interface. For those of you who are on a PC, you would just invoke the idle development environment. All right, and this is what it looks like. All right, so we sort of did that before. We actually typed the programs in. But what we'll do this time is we'll actually, well, let's actually do that. Print hello world. Because what you're going to do next is something that I'll have you do as part of the first lab. And that is to actually just take this and cut and paste that information into a new text file. Because what this will do is it'll give you a sense of what is actually Python and what is not Python. So I'll create a new window, and I'll just paste that in there. Copy that window. All right. Now, if I try to run this program, there's a couple of things that won't work. All right, we just cut and paste it. These are not part of the language. These are just prompts that basically tell Python or tell you that Python is waiting for you to type something in. We cut and paste it from that window, so this is actually stuff that we can't use, right? And then what we have next is the answer that comes out of the program. So we don't really need that. Now for Python, you can actually comment things out by using the pound sign. So the pound sign basically tells Python, ignore this, but keep it around so that whoever wrote this will be able to read this information, right? So same with this. We don't need this part because that's not part of the program. It's just a prompt. It's just a prompt that tells you that that it's waiting for you to type something in. And again, what we're doing now is we're actually commenting out. Oh, that's wrong. Okay. Yep. Thank you. I think next time somebody should probably be here to witness the what goes on, because it's entirely mysterious. Because I get this thing running, and then I have witnesses here that I'm over here, and then it will automatically go up.
Yeah. Okay, I'll make a note.
Yeah. Yeah, thanks. Okay. Okay. All right. Okay. All right. So this is your little program. If I try to run it now, and this is what you'll be doing ad nauseum. You'll be writing something, run it. You can either check it first to see if there's anything wrong with it, or you can just run it. I typically just run it. And I'll say, oh, it must be saved. Right? So you have to write this out into a file. And I will call this my second program.py. Save it there. And then it works, just like that. So that's programming. Okay. What programming involves is you can create a file, type commands in it, and then run it. Okay. In other programming languages, there's an extra step where you would type the commands, compile the program into machine language, and then take that machine language, format it so that the computer can now run it. All right. So some of you may hear the word compiling. That's all it means, is that it's being converted into machine language that the machine can understand. Python and other languages are what are known as interpreters, which means that as you type something in, it's actually doing that conversion right away, so you can actually get immediate feedback. The advantage of interpreters, Python, is that it's easy to make that experimental experimental changes and see what's happening. The disadvantage is it's a lot slower than other programming languages. Some other programming languages where you type everything, compile it, and then run it, is the fact that it'll run much faster than Python. However, I think the ability to be able to prototype a program is much easier in the Python environment. And if you need it to be faster, you can team up with a computer science or software engineer. Okay. The idea for you to sometimes do programming is to sort of make a concept of what you want to do, right? It may be slow, but for the most part, you can probably make it work in a much shorter period of time in languages such as Python. Okay. So that's fairly straightforward. We talked about variables. So you can just assign a variable, answer equals 42. And we talked about typing, the type of being able to figure out what it is. What I also want to talk about is starting off variables in known states that are sort of 0 or nil. So let's take, for instance, the number count. Variable count, I can set that equal to 0. Let me make this window a little bigger. View preferences. Size. So as big as it gets. Let's bullet. Okay. Count equals 0. What type is it? An integer. And I want to introduce the following statement. Count equals count plus 1. When I started programming in high school many years ago, I looked at this and it always drove me crazy because I always thought, okay, that's an equation. I'm going to try to solve for count. And if you think of it that way, you'll go crazy too. It turns out this is actually an operation that says take the current value of count, add 1 to it, and deposit back into that variable. Right. Again, to repeat, take the current value of count. So what's the current value of count? 0. Add 1 to it, and then deposit it back into the value count. And we'll see this as in terms of adding, but we'll also see this in other forms. So if I just did that. So if I say print count now, what number should I have there? Right. Now if I repeated this command, if I said count equals count plus 1, executed that again, I said print count, what number should I have? 2, very good. Hey, we're getting there. So basically, if you want to do this to 100, you'll do this 100 times, right? Hopefully you'll say, nah, that's crazy. That's no way to do that. That's fine. So let's do the same thing for a variable. Let's call it sum, and call it 0.0. Let's look at the type of this value. Oh, in this case, if I said sum equals sum plus 3.14, I hit return, what value should I have in sum? That's right. If I said sum equals sum plus 3.14, if I say print sum, what will I get? Right. Just so sometimes you'll run into people who are a little pedantic about how they program, you will see something like this where it says sum plus equals 3.14. Right. This is just a shortcut for this. You'll sometimes see this in programming languages. So now what will sum be now that we've done that again? I didn't call you, but go ahead. You think?
Yes. Wow, that's wrong.
No, because you ran this again.
I don't know.
This is equivalent to this. Okay. I just want you to see that in case you actually look at code and then you see this and you say, what the heck are they doing? This is just a shortcut for this. Yes, Rebecca. Float means it can allow for decimal points. Okay. Integer is all zero. It's all ones. I mean, not all. All whole numbers, negative or positive, right? And then when something's floating point, you can have decimal points associated with it. The reason for floating point values, or for floating point values, is pretty straightforward. You want to count the fractional values. The reason some languages actually hold on to integers is because it's a much quicker process. And sometimes all you really need are whole numbers to work with. So it's sort of an efficiency, from an efficiency standpoint. The representation for integers is much smaller than the representation for floating points. So if you are in a situation where you have millions or billions of values, the floating point will take more memory space than integers. It's a good question. So we've seen this process occur for numbers. What about non-numeric values? All right. How does that actually work? Well, let's actually do that. Let's create a, let's call this start string equals. So before we started zeros, now we're going to just start a string, a null string. And we do that by just giving it 2 quotes, single quote in this case. I can use double quotes in the other situations. And we'll do the same thing that we just talked about. I will say something like start string is equal to start string plus A. I do that. String. I type it again. What should I get? A, Canadian. Okay, because what it's doing is a string, a plus sign is a concatenation operation. It actually takes a string or character and puts it together. So if I gave this again, if I invoke this again, I'll have 3 A's. Does everybody see that process? I want you to see this process before we actually talk about for loops, because this is one of the things that you'll be doing within a for loop, is to either add or subtract from some sort of data. Right? And in this case, we're just dealing with very simple data types here. Any questions about that process? So if you see variable equals the same variable plus or whatever, you're processing that and then putting it back. So we've talked about strings. Now let's talk about lists. So let's go start list. And before we continue, does everybody remember what a list can do? or what the list is used for.
Multiple elements.
That's right, multiple elements and of different data types. In this case, however, we're just going to stick to one data type, and we're going to create an empty list. And to create an empty list, you basically do the following. You open bracket and close bracket. If I printed that out, a list. If I say print len of start list, the length of a list. Okay, so if I print len of list start list, what number should I get? Should be returned? 0? Did you say 0? Yeah, yeah. Yeah, that's what I meant to do. I meant to say 0. Because the list is empty, it has nothing in it. So let's actually put something in it using this format. I can actually say something that says start list is equal to start list plus, and in order for it to be considered an element, you have to put this little bracket out here. And then let's put the number, or hello. Okay. Again, start list is a list. We're going to add an element to it. So if I say print start list, one element there. And we can verify that by saying print len start list. Tell me that's one element there. I can add another element to that. I can say start list equals start list plus 3.14. The plus, one of the reasons I'm using the plus here is because it all depends on what type it is, okay? In a list, this plus will take some value and put it into the list. So if we now look at print start list, we've concatenated that information into the list. If it was a string, what it does, the plus sign has a different meaning. Okay, if it's a string, it means that if the other string, you concatenate two strings, right? You'll add two strings together, or you concatenate two strings together. If it's a number, it'll actually do the addition, as most of you are familiar with. But again, the plus sign, what it does is very dependent on the data type. And that's why one of the things that I keep repeating is that for functions, you need to know what kind of arguments go into the function and what kind of data type is associated with those functions. Because if you try to put a data type that is inconsistent with a given function, it won't make any sense. Okay. One of the things we'll do is we'll write a little function to calculate the average of a set of numbers. Well, what happens if you give it not numbers, but a list that has the quick brown fox jumps over the lazy dog? There is no concept of a average with regard to string data types, right? So that's why it's very important to understand what kind of data type you're working with and what kind of operations you can apply to that. Right? So we've been using that, but in most programming languages, there's more than one way to actually do something. So you can actually, if I do a dir on start list, you can also see that there's a append function. So what I can do, instead of doing this part right here, I can say start list dot append, right? And you can add whatever you want there. So in this case, we can add a negative integer. again, in most programming languages, there's many ways of doing something. Some are a little more obvious than others. Often, if it's a good programming language, there's only typically a few ways to do it, just because trying to do it in a fancy way can be very hard for somebody else to read. So just understand that there are different ways of doing things, in much the same way that when you write an essay, it's not like you write the same essay as somebody else. Of course, if you copy it, that's a different story. But yeah, that's people have different types, different styles of programming. So it's very common to have somebody do one thing, sometimes inefficiently, but it's very readable. So, all right. Let's see what else. So variables. So one of the things that I recommend people do is click on some of the links that I have in Lab A. That documentation is probably, it's sometimes very terse, not easy to read, but it's what I want you to get into the habit of actually reading it and trying to pull out information. It's a different type of reading that some of you may be used to, but I think it's an important skill. In much the same way that in the midterm, I gave you the documentation that was associated with the decimal to binary conversion. It's not the easiest thing to read, but all the information is actually there. And it takes a little bit of skill to actually tease out the critical pieces of information from those kinds of documentation. Unfortunately, that's how most engineers will document things. So trying to get into the habit of familiarizing yourself with these types of documentation is good practice to understand. So now that we have a list, we talked about being able to access the different elements. Print start list of 0. One, and so on. Just to review. Right? So fairly straightforward. Let's see what else. Most of the time, when you actually get data, it'll be in the form of a string. So let's start with the following. Numbers is equal to strings. You really can't process these things. If I said print numbers of 0, what is your guess as to what it'll give us? Keep in mind it's a string. Why? Why do you say error message? Because it's what in a list? It's not a list? Okay, so that's a string is a special kind of list. In fact, print numbers. Right. So it's going to go through each one of those. We can actually create this, make this a list into the string into a list. You can say new numbers is equal to numbers dot split. However, we can't operate on these because these are still strings. They're individual strings. So now if I say print new numbers of 0, of 1, and if I said print new numbers of 0 plus new numbers of 1, what do you expect? Or intuitively, what would you think would happen? What's that? These are still strings. Okay. These are still strings. Again, data type is important. If in order for you to get the answer that you were expecting, I would have to do the following. Because these were strings originally, we have to do what's known as casting to convert it into a number. It's a little crazy that you have to do this, but that is how computers work. They don't typically end up with numbers initially. They have to work with characters. It has to take those characters, and if they're numerical, somehow go through another translation to make sure that they are numbers. All right. Any questions about that? I think it's fairly straightforward. So let's introduce a construct that will become your friend, and is one that's probably a little weird, and that is the for loop. Okay. So for loop basically says, if you give me a list, I will go through each element of that list for you. And we could do whatever you want for each element of that list. Okay. So let's actually start with the following string, just to illustrate a couple of things. So my sentence equals if I gave the following for loop for I in my sentence, what this construct is saying is that I want you to go through the string, pull out each character, and do something. What that something is up to your imagination. So the for loop requires you to indent, and what will happen is that the next set of commands will be executed every time it goes through this loop. Right? So let's just say, for the sake of argument, just say print I. So this is where it's taking the information from. The for loop will just go through each character here and print it out. We can do other things for every character here, but for this, in this case, we're just going to say, just print it out. And that's what that for loop just simply did. It just went through each of those lists, each of those characters. We can do the same thing for I in my sentence. And let's do something a little different and say print this character is I. So if I run this, it's simply doing nothing more than just concatenating that part over there. So the for loop is actually one of the most powerful constructs that you'll ever run into. It's sort of similar to in Excel to you actually selecting a whole column, right? When you select an entire column in Excel, think of yourself as creating a for loop that will just go through each one of those elements of those cells. Okay, so that's one way to think about that when you drag that mouse across several cells. It's as if you're creating a for loop where each of those elements in that selected cell will be processed in some manner. Okay. So that's for a string. Let's actually scroll up. Let's see if it's saved. This one? So in this case, I just said print I. Yep, you can put a comma there, or you can put a plus sign there also. So print has different ways of getting things in there. Actually, a plus sign, yeah, plus sign will work because it's still a string. Okay, so that's a legitimate. And we'll go through situations where it won't work. So this is for a string. What we typically want to do is create a, let's say, my words is equal to my sentence dot split. Okay. So one nice thing about using idle is that it's context sensitive. So that if it knows that if you type in a particular function, it'll sort of give you an idea of what that looks like, right? So it'll give you sort of a hint to do that. In fact, there's a lot of integrated development environments, IDEs, that will show you everything as you type things in. And some people like it, some people don't. I'm agnostic to a lot of tools. So in this case, if I don't give an element there, an argument, it's just going to split it based on spaces or white space. So now I can say print my words. And the cool thing about this is that you can do the same thing with the for loop. So I can say for I in my words, print I. What will happen here? So it allows you to go through each word. So the for loop is very powerful because it will give you an ability to take a large list and go through each element, and do something to that element. So that's the concept of a for loop. Any questions with that? So I'll try this. It may or may not work, but it does work. So that's the for loop. Now suppose print my words. I'm trying to think, what do we want to do with this? Let's do the following. Let's make a new no space sentence equals, so we're starting with, string there. If I say for I in my words, and I say no space sentence is equal to no space sentence plus I. I mean, from the variable name, you know what it's supposed to do. But the idea here is the fact that you will actually go through each of those elements and put it together. Likewise, if I said CSV is equal to CSV sentence is equal to this, and I say for I in my words, CSV sentence is equal to CSV sentence plus, how do we make this into a CSV?
What's a CSV?
Comma separated, comma separated values. Okay. So we did this for no spaces. So what will we put in here? Okay. Just a plain comma, or what do we have to do? Very good. Put quotes on it. Okay. What do we want to do next? Want to print it? No, it's fine. So what do we want to print? Okay. Right? Okay. Okay, based on that output, how would you change that? It's okay. That's exactly what you want to do. You want to make these mistakes so that you look at them and say, why didn't it work? And in your head, you probably say, oh yeah, it should connect it there. But as we said before with the example of the driving example, where you said, oh, you turn, and then you forget to turn. But if you didn't tell the car to turn, you're going to do that. Same thing with here. You put the comma there, but there was a missing component. So let's actually fix that. And I can't emphasize enough that for you to become good at programming, you have to make all these mistakes. There's really no way around it. And you can talk to any programmer and they'll tell you that, yeah, I've just banged my head against silly little things. But once I saw that, I always remember now that that's something I can avoid in the future. So what you've just done is you've learned the fact that, oh, wait a minute, I have to do with something with I. So let's do that.
Where does the I come from?
The I comes from just the process of up here. So think of it as a small container. You have a big pile of something, and what you have to do is think of the I as picking one element from that pile, and then doing something with it. it'll do it sequentially. Okay, it'll always do things sequentially. So, which is, for the most part, that's how it will actually do that, step by step as you go through that. There are some situations where, I won't discuss it now, but there are some other data structures where that ordering is not necessarily definitive, but that's a separate lecture. So CSV sentence, CSV sentence. So this is where we are. What's next? Plus I. And we don't need to print it right now, but if we want to, we can. Okay. What you'll see is how it's actually being formed. So every time we pick up a letter, it'll tack it on there and it'll print it out. So if we do that, oops, CSV send. Oh, wait a minute. Oh yeah, it did. Why do we have all this junk here? Well, we used it up there. We never initialized it. So it still has all the old stuff in there. And that's why initialization is important. So you want to say CSV sentence is equal to that. It's almost as if you used a number, you calculated it, and it still had a number in it. And then you use it for adding something. It still had that old number in there. Well, that's not what you want to do. You want to make sure that you clear out that variable if you're ever going to use that again. So let's go through this really quickly and show that it does work. First part, but that's okay. You get the gist. For loop. So it's a powerful thing. It's a great way to mess things up. All right. So I would suggest giving the first Python lab a try. It's very easy, very straightforward. And next week, Brian will be giving the database lecture, and Blair Tinker will actually come in for the beginning of one of the Tuesday to tell you about the GIS online accounts that he's set up for you, and the part of the project. So this will be for project 3. But play around with Python, get familiar with it, and the rest of the other examples will hopefully be straightforward. So again, look at the labs. I'm going to go through the labs verbatim in class, so you can ask questions as we go through each of those elements in the Python labs. Questions before I break? All right. There'll be no office hours. I still have to finish grading, so I'll hopefully get that done pretty soon. Thank you, and we'll see you next week.
Why didn't you ask the girl what she did? It's trouble.
Well, because I was just tired. She restarted my machine. There's definitely something wrong, and that's kind of why I don't know. They should fix this. I I shouldn't have to be messing around with this.